Hello and welcome to Electrical and Electronic Principles P1. In front of you you see exactly the same circuit that you've been building and simulating in Multisim and practically. Once again, the voltage will be 12 volts. We have two banks of resistors and they are in parallel but joined in series. You're required to find things such as the total resistance RT, and where I've asked you to find the circuit parameter, I've also given you the related formula. If you like working with triangles, you can see how all of the three major Ohm's law formulas are derived from the triangle. To find RT in a series circuit, very easy. You simply add together all the resistances and that gives you RT, but it's a little bit more difficult in a parallel circuit. We have to use something called product over sum. There is a slight warning involved with this technique, and that is it only works with two resistors at a time, but we can get around with that. It's not a problem. So what we're going to do, we're going to look at R1 and R2, and we can see that R1 is 220 ohms, R2 is 100 ohms. The product of those is simply their value multiplied together. And the sum is 320, that's 100 plus 220. And that's divided into 22,000, which gives a result of 68.75 ohms. So R1 and R2 are represented as 68.75 ohms here, and I've redrawn the circuit for clarity. Once you've done that stage, you will apply the same technique between R2 and R3 to find the value of these two resistances together. That's what's happened here. And you can see that the total resistance of those three resistors is 27.9 ohms, represented here as one resistor. Next, you will do exactly the same technique for this parallel branch, and when it's done correctly, you will have two resistances, each representing one bank of resistors. Now to find RT, we simply add those two resistances together, as you see has happened here. R1 plus R2 is equal to 36.7 ohms. And you can see we have now worked out the first parameter. The second parameter, the total current, is the current flowing through the circuit and back. So it goes through the bank of resistors, through this bank of resistors and back. When it gets to a bank of resistors, it splits, in this case, in three different directions. And the amount of current depends on how big the resistor is. So for example, this 47 ohm resistor, which is twice as small as the 100 ohm resistor, will conduct twice as much current. The current then joins up again here and becomes 1, and then splits, this time in three ways because a little bit of current will go through the meter. But only a very little bit of current. To find IT, we use I is equal to V over R. R we've just worked out, that's RT, and V is the applied voltage, which is 12 volts as mentioned earlier. When you do that sum, you will find IT is equal to 326 milliamps. Now, we could find the current through R3 at this stage. We could do. And if we were looking at the actual resistors here, we might say, for example, that R1 is 4 times larger than R3. Therefore, R3 will conduct 4 times more current than R1. And R3 will conduct 2 times more current than R2. But it's much easier in actual fact to work out the voltage across this bank and across this bank, and then to apply Ohm's law to find the current going through R3. So that's what we're going to do now. Once again, Ohm's law, V is equal to I times R. The circuit current, 326 milliamps, times by the resistance of each bank. So there's the resistance of the bank. The current, 0.326. Therefore we get a volt drop across bank 1 of 9.122 volts and a volt drop across bank 2 of 2.86 volts. Kirchhoff's law tells us that the sum of voltage drops in the external circuit must always equal the applied voltage, which in this case is 12 volts. The sum of external volt drops is 11.99 volts, and that's more than close enough to satisfy this particular criterion. We've also now worked out two different things. Firstly, we've worked out the voltage VR5, which is required from the parameters above. VR5 is equal to the voltage across bank 2. We also now know the voltage across bank 1, which is also the voltage across R3. So we can use Ohm's law for current. I, R3, is equal to the volt drop across the bank divided by the resistance of R3. IR3 is equal to 0.194 amps. Finally, we can work out the total power. Going back to the beginning, you will see there are three equations for power. The equation that I'm going to use, P is equal to I squared R. I square the current and then times it by the total resistance, and I end up with 3.9 watts. Using either of the other two formula will give you a very, very similar result. A few tips on your submission. You should bold and underline answers. You should explain your procedure. You should use diagrams where appropriate. You should signpost what you're doing. Doing these things will make your work much easier to mark and ultimately mean you will get better grades in the future. Thank you for listening. Goodbye and good luck.